Look up. Tonight, if the sky is clear, you will see a light rising in the east just as the sun sets. It is the brightest object in the midnight sky, dominating the constellation of Gemini. To the ancient Romans, it was the king of gods. To the astronomers of the Renaissance, it was the key to the mechanics of the universe. It is Jupiter. And right now, in January 2026, it is at opposition, the closest it gets to Earth, shining at magnitude -2.8. It looks peaceful, a silent sentinel watching over the night. For centuries, we told ourselves a comforting story about that light. We called it the shield, the protector. We believed that its massive gravity, 318 times the mass of Earth, acted as a cosmic vacuum cleaner, sweeping up the asteroids and comets that would otherwise slam into our world. We believed that we were safe because it was there. But new simulations running on the world's most powerful supercomputers have revealed a darker truth. We were wrong. Jupiter is not our shield. It is a sniper. It is a wrecking ball. And 4.5 billion years ago, it didn't just watch the inner solar system, it destroyed it. The myth of the static solar system, the idea that planets stay put and space is safe, died on July 16, 1994. That was the day humanity watched a planetary execution. Comet Shoemaker-Levy 9 had been captured by Jupiter decades earlier, but it wasn't just captured. In 1992, it passed too close to the giant. Jupiter's gravity, acting like a tidal rack, ripped the comet apart. It turned a single mountain of ice into a shotgun blast of 21 fragments. Over 7 days, we watched them slam into the atmosphere. Fragment G hit with the force of 6 million megatons of TNT, 300 million times the energy of the Hiroshima bomb. It left a scar in the clouds that was larger than the Earth. If that object had hit us, civilization would have ended before it began. Seeing those scars, the media dusted off the old theory. Jupiter took the hit for us. It felt intuitive. It felt safe. But astronomers looking at the data saw something else. Jupiter didn't just passively absorb an impact, it had actively grabbed a comet from the outer dark, pulled it in, fragmented it, and then swallowed it. This was orbital mechanics weaponized by gravity. And it forces us to ask, if Jupiter can do that to a comet, what did it do to the young Earth? To understand the crime, we have to look at the survivors. Mercury, Venus, Earth, Mars, the 4 rocky worlds. For decades, computer models of planet formation worked perfectly for Earth and Venus, but they always failed when it came to Mars. In every standard simulation, Mars grows to be as big as Earth. There is simply too much material in the disk for it to stay small. But in reality, Mars is a runt, only 11% the mass of Earth. This is the small Mars problem. In 2009, researcher Bradley Hansen proposed a radical solution. Mars is small because it ran out of food. Hansen showed that you can only build a small Mars if the disk of rocky material was cut off, truncated right at Earth's orbit. If the universe took a knife and sliced the outer edge of the inner solar system. But gravity doesn't use knives, it uses giants. Enter the Grand Tack Hypothesis. 4.5 billion years ago, Jupiter formed near the snow line, 3.5 times further from the Sun than Earth is today. But it didn't stay there. The young Sun was surrounded by a thick disk of hydrogen and helium. Jupiter, massive and hungry, cleared a gap in this disk. But the gas was still flowing inward, falling into the Sun, and like a raft caught in a river current, Jupiter was dragged along with it. It began to migrate inward toward the Sun, and as it moved, it pushed a wall of asteroids and planetesimals ahead of it. a gravitational plowshare of the size of 1,000 Earths. This is how the small Mars problem is solved. Jupiter plowed through the region where Mars sits today, scattering the material, starving the future planet. It pushed everything into a narrow ring at 1 astronomical unit, the ring where Earth would eventually form. But Jupiter didn't stop. It reached 1.5 AU. It loomed over the inner solar system. In many other star systems we see today, the gas giants don't stop. They migrate all the way in, becoming hot Jupiters, roasting near their stars. If Jupiter had done that, it would have plowed through the Earth's orbit. It would have eaten our cradle. We were saved by a second giant, Saturn. Saturn formed later and further out, but it was lighter, faster. It chased Jupiter down. When Jupiter was sitting right on Mars's doorstep, Saturn caught it. The two planets locked into a gravitational dance, a mean motion resonance. For every 3 times Jupiter orbited the Sun, Saturn orbited twice. This resonance changed everything. The rhythm of their orbits altered the way they interacted with the gas disk. Instead of being pushed in, they were pushed out. Like a sailboat tacking into the wind, the two giants reversed course. They retreated. They sailed back into the cold dark, leaving behind a cleared, truncated disk of rocky debris. The debris that would become Venus and Earth and a starved, stunted Mars. The Grand Tack was complete. But there is a darker chapter to this story, a chapter written in the graveyard of the first generation. When we look at other stars in the galaxy, we see something strange. Most of them have planets orbiting very close in, massive super-Earths with thick atmospheres orbiting faster than Mercury. Our solar system has nothing inside Mercury. It is a hollowed-out ghost town. Why? The simulation suggests that we did have super-Earths, a first generation of planets that formed before us. But as Jupiter migrated inward, its gravity captured swarms of asteroids, whipping them into frenzied elliptical orbits. This triggered a collisional cascade. The inner solar system became a grinder. The high-velocity impacts pulverized the first generation of planets, reducing them to debris and dust. The debris lost its momentum in the thick gas and spiraled into the Sun. Jupiter didn't just prune the tree, it burned the forest. It destroyed the first generation of worlds. We are the second generation. We formed from the ashes left behind after the giants retreated. We are built from the scraps of a destroyed world. So the shield is dead. Jupiter is a destroyer. But if that's true, why are we alive? Why does Earth have water? Earth formed in the hot inner zone of the solar system. It should be a dry rock. Any water here should have boiled away billions of years ago. We needed a delivery. Planetary scientist Kevin Grazier ran the numbers. He found that Jupiter doesn't just eject comets, it acts as a sniper. Its gravity grabs icy bodies from the outer system, comets and asteroids loaded with water, and slows them down. It decouples them from the outer dark and slings them into the inner solar system. But here is the miracle. It slows them down just enough. If they hit Earth at full speed, they would vaporize the planet. But Jupiter delivers them at a velocity where they can survive the impact. It wasn't an attack, it was a terraforming event. Jupiter bombarded the young Earth with ice. It delivered the oceans we swim in. It delivered the carbon in our bodies. Jupiter acts as a gardener. It pruned the first generation and then watered the seeds of the second. This is the unifying lens. We exist because of a cosmic accident. If Jupiter hadn't migrated in, Mars would be huge, and the asteroid belt would be a war zone. If Saturn hadn't caught Jupiter in time, Jupiter would have eaten the Earth. If Jupiter hadn't acted as a sniper, Earth would be a dry desert. We are the beneficiaries of a chaotic dance, a migration that stopped exactly at the point required to clear the board but spare the player. So this January, when you go outside and see that bright light rising in the east, don't just see a planet, see the architect. We are finally going back. In December of this year, the Europa Clipper spacecraft will fly past Earth, stealing a little bit of our gravity to fling itself toward Jupiter. It is going to look for life in the oceans of Europa, oceans that exist because of Jupiter's gravity. And in the decades to come, when we build the Habitable Worlds Observatory, we won't just be looking for Earths, we will be looking for Jupiters. Because now we know, to find a home like ours, you need a giant like that. Jupiter didn't shield us, it made us.